Hello everyone, my name is Teng-Fang Hsiao. Today I'm going to introduce our research. Natural light can also be dangerous. Traffic sign misinterpretation under adversarial natural light attacks. Here is the outline. In the introduction part, I will quickly go through the history of adversarial physical attack and also introduce the value of its research. And in the later part, I will stem from the relative work and delve into our architecture and algorithm. Finally, experimental results. I will demonstrate our proposed method can not only reach high performance in the digital domain, but also in real world. So, in 2014, Yan Goodfellow found the existence of adversarial attack, which is some subtle noise but also capable to hugely impede the artificial intelligence. In 2017, Kurakin found that adversarial attack isn't only exist in the digital domain, but also capable to create it in the real world. In 2021, Gunnarsson Benton decided to utilize projector as the source of physical adversarial attack. In 2022, Song found that shadow can also be the source of adversarial attacks. And in 2023, we found that natural light can also be the source of adversarial attack, and it is also easier to control than all the previous methods. So what is the importance of this research? The first point is the existences. We discovered that natural light can serve as a potential source of adversarial attacks, posing a threat to our daily life. The second point is the accessibility. Attacker can easily create attack pattern using a flashlight or sunlight. The last point is stealthiness. Our attack is challenging for victim to notice due to its natural-like appearance. So the shadow attack is mostly related to our proposed methods. In the shadow attack, they try to reduce the yellow dimension in CIE color space to mimic the shadow pattern in the digital domain. But this isn't the story for the light projection. It is more obvious when you're looking at the left image that in the light project area, you can see the red region get more saturated. But its saturation cannot be acquired by only adjust the yellow dimension, illumination dimension of the CIE color lab space. So what is the goal of natural light attack? We want to exploit natural light source to deceive the classifiers. To achieve this goal, we divide our test into two parts, training light generator and inference adversarial light. So here's our overall architecture. The first part, training light generator. We want to simulate light perturbation for a given image, considering its corresponding position and shape. In step 1.1, we'll collect a victim image and its corresponding light interference data. And in step 1.2, we will detach the light position of this capital S by simply subtract the difference in two image with some morphological operation to like denoising to acquire high quality mask. Last step is most straightforward. Just feed all the data into the generator G, and we want the outcome to look similar to our input capital X. For this mean, we just minimize the error mean square error for this to distribution. And the second part is the inference adversarial light. We want to identify the most parlous light pattern for victim image and the classifier. So in step 2.1, we'll generate the light emission being given by the provided mask n. So the result will look like this, XADV. The second part, step 2.2, is compute the score of this simulation. We'll feed this XADV into the classifier and we'll output the predict results with the largest. We will denote the largest of ground truths as the score of this is XADV. And in step 2.3, we will utilize this information, the score of this XADV and all the previous results to update this mass and update the geometry property like center position of radius of this mass using Zeroth Order Optimization. And this is steps we'll go through repeat and repeat again. So the basic setting of our experiments, we will utilize two datasets, GTSRB and LISA, which is a German traffic sign dataset and US traffic sign dataset. And also the two classifiers. The first classifier CNN1 is the classifier using for evaluation in private work. And the second classifier is CNN2, the current cargo benchmark for GTSRB task. For digital setting, the first thing you will notice is that we divide the test data into two categories, day and night. For the recent lab, we will utilize the sunlight as the light source in day, but we cannot access sunlight in night. So for the substitution, we utilize flashlight as the source of our attack in the night. So we need to divide the test data into two categories for fair evaluation. And the second thing is that we label some images from the original dataset to train the light generator. So as you can see, in the test table that our proposed method can reach quite decent attack performance in different scenes and cross different models. And the second thing is that, as you can see, as the queries increase, the attack performance also escalate. But the other side, the trade-off of the query is that the inference time will also increase. It is the last part and the most important part, physical evaluation, because we are proposed a physical adversarial attack method. So we test our proposed method on the real working traffic sign around our campus. And for each attack, we will train light generator for each sign. We capture source image without any light manipulation, which is X in previous slide, and a 20-second video with random light manipulation applied throughout, which is the. And in the next step, we will crop each frame as the light interference data, which is the X capital in the previous slide. And will take some time, but will take too long to fine-tune the light generator and inference the adversarial light pattern. So as you can see the results here, it has two parts, the day part and the night part. For each part, the leftmost column is the original results. And you can see this is the prediction result and confidence of each class, confidence of this class. And in the middle column is the simulation in digital domain. And in the right column is the physical attack result, which we will simulate the digital domain. We will simulate the inference outcome of the digital domain. So as you can see, this is figure that demonstrates that our proposed method, natural light attack, is capable to mislead the current classifier, including the benchmark label. So here, this is my presentation. Thanks for listening.